a long time to be sitting and thinking.
Good luck. You cat dog.
I need you to be paying attention. Have a seat. Have a seat. So how do we explain where this is not? Think in your head first. What happened to that thing? Mabel?
Happened to it? Well, imagine a dog.
Okay, I want a real answer. Like, where do you think the rock really is?
Probably like close to the like shallow pipe.
Okay, Cash?
Might have been washed up and taken into the sea, or it could have turned into dirt or sand.
Okay. So all the pieces of this rock that are pretty much gone now, where are all those pieces? Lincoln?
The ocean.
What do you mean?
I mean, it most likely over a long time, the water actually caught the Grand Canyon. So over time, it almost like eats away at it, and then eventually there's almost nothing left.
Okay. So I actually want to think about Mabel's idea about the dog. So without being silly about it, if a scientist said, a dog ate the rock, why are the other scientists probably going to be like, no, that's not right? And but the scientist said it was a magical dog that eats rocks. Why are the other scientists probably going to be like, no, I don't think so? Think about that. Think about it first. Why are the other scientists going to think that that's probably not the right idea?
Because they probably know about how water can cause stuff like the Grand Canyon.
Okay. Mabel, what were you going to say?
They don't know that the scientist is just using it in its imagination, and
Ah.
that what it means is the dog's stomach is the ocean.
Ah, okay. So but that's an interesting point about imagination, Mabel. Like, why does it take imagination to think about these pictures? Think in your head first. Why does it take imagination to think about these pictures? Cash. Oh, I thought you had an answer. Why does it take imagination? Go ahead, Mabel.
Because sometimes scientists need to use the imagination to like find stuff out and be creative of what they think.
Okay. Lincoln, what were you gonna add?
Because you'd have to imagine the water going over like a long time. Water going. It's like water goes.
Okay. So there's actually the next video that I'm going to show you is actually kind of a simulation or a model, like we talked about before with models, showing how this works. So take a look.
That's clay.
Yeah.
See clay?
This is a sea cliff. It gets eroded by the waves. A cave is formed.
There's an invisible dog
The
eating
cave
away.
gets hollowed through. If it extends to the other side, an arch is created. The top part becomes too weak and it collapses, leaving a stack.
No, that's wrong. The dog is eating.
The dog like put it in his stomach and then it goes to die. That was the guy's brother.
Is that a basin?
Yeah.
Mm-hmm. All right, I'm going to play it one more time.
I want to see it so the dog can eat it. I want to see it so the dog can eat it.
This is a sea cliff. It gets eroded by the waves. A cave is formed. The cave gets hollowed through. If it extends to the other side, an arch is created.
Those are the two bears.
The top part becomes too weak and it collapses, leaving a stack.
There's a bear right there, and the head's gonna fall off.
Gets further eroded to finally leave a stack.
fall in the sea, you get
I wish that part where that girl is standing would collapse.
All right, so now
Hilarious.
I want to think back to our goal of designing a bridge. So we saw some examples of fast changes, and we saw some examples of slow changes. Because remember, that takes 100 years. The video makes it look like it goes fast, but it actually took 100 years with those other pictures. Why do you think the engineer who's designing the bridge should think about both fast and slow changes? Think in your heads. Why should the engineer designing the bridge think about both fast and slow changes? All right, what do y'all think? Why should the engineer designing the bridge think about both fast and slow changes? Cash.
water could rise, like, it could, and like, it would, could be like, if the water was eating the bridge, but it was just breaking the bridge.
Okay. What else?
Right.
Lincoln?
You'd need to, I see that's a peninsula. It looks like a peninsula because it just goes through. You'd want to build it like, inland.
Oh, okay. Why?
Because the peninsula, it's not super thick. The water over 100 years will maybe create the cave, and that can cause the stuff to fall,
Okay.
and that'll become a stump.
Okay.
And that can cause the bridge to fall
Okay.
and collapse.
And you get eaten by
Uh-huh.
the sea.
What else?
That would be
Smart.
smart. You could build like, so on top of the grass, you could build like a wooden or brick surface, and attach it to two sides. So if the entire thing collapses, there's still a bridge there for people to like finish up the peninsula.
Okay. All right, so now we're gonna do some drawing. And so I want to revisit why would engineers make drawings before they make the actual bridge? Lincoln?
To help make sure it'll work.
Okay. So what we have here is you have,
You have to fill out.
well, yeah, so you have, this is the river. Everybody look at what I'm pointing at here, please. This is the river. And so you can kind of see there's sand, and there's like boulders, and there's like big rock areas. So you can kind of think that this is like a 3D. So you have to decide where you're gonna put your bridge, and then draw a picture of your bridge. And then after you're done drawing your bridge, or as you're thinking about your bridge, be thinking about what's a quick change that might happen that's telling me where to build my bridge, and what's a slow change that might happen that's telling me where to build my bridge. And then you can even talk about the building materials you want to use. So like, is it gonna be made out of wood, metal, concrete, things like that. So what questions do you have about what you're supposed to do?
Well, that looks like
Daddy,
water.
I do have a question.
It does look kind of like water, but it's sand. What's your question, Mabel?
Is how you're allowed to color it?
You can totally color it. But I want you to draw the bridge and fill out these parts first.
Oh, ants.
So I'll get you your pencils. They're right here.
Oh, ants.
I can't wait to color.
Well, draw it first, and then you can color it in. Go to it.